our topic first is Cartesian product. So for understanding the Cartesian product, we will see first ordered pairs. What are ordered pairs? If a pair of elements, if a pair of elements are in a particular order, means order cannot be changed. In a particular order, then such a pair is called ordered pair. Then such a pair called ordered pair. Like we used to use comma for writing it, like two objects A, B. For example, A, B written in the bracket. This is an ordered pair. A is the first element and B is the second element. This is the ordered pair. Why? Because order is here, order matters. A is the always first component of first element. A is first element. We can say first element or first component, element or component. We can say component also. First element of first component, and D is the second element. We cannot, so this is the ordered pair. So two ordered pairs are equal if their corresponding elements are equal, then only. Means if AB, one ordered pair is AB is equal to CD, it is only possible if A is equal to C and B is equal to D. Then two pairs are. So generally we are using graphically ordered pairs representing in a Cartesian coordinate system. Already we know that Cartesian coordinate system in class 10th also we did. This is x-axis and this is y-axis. So if you want to just suppose this is 1, 2, 3, 1, 2, 3, and here 1, 2, 3, 1, 2, 3. So this point, how will you represent this point A? This point will have x coordinate 3 and y coordinate 2. You cannot change the order. For this point, 3 will come as a x coordinate, 2 will be y coordinate. So this is the case of ordered pair where 2 is called abscissa and 3 is abscissa and 2 is ordinate. Okay. X coordinate is also called abscissa and y coordinate is also called ordinate. So this is the example of ordered pair. So two ordered pairs can be equated if their corresponding first component is equal to first component of the second ordered pair and second component will be equal to second component of the second ordered pair. So if the question is find the values two ordered pairs are given, so we have to equate them separately. For example, the question is find the values of find the values of A and B. Find the values of A and B. if two ordered pairs are equal, if A minus 3 first component, B plus 7 second element is equal to 3 comma 7. So as I told you, we can say that A minus 3 is equal to 3 and B plus 7 will be equal to 7. So therefore A will be equal to 3 plus 3 6 and B will be equal to 7 minus 7 0. So we get the value of A and B. So we can equate. Now we have Cartesian product of two sets. What is the Cartesian product of two sets? Cartesian product of two sets. Cartesian product of two sets, I will explain you first, then I will write the definition. Suppose A is a set of elements 1, 2 and B is a set of elements A, B and C. Then Cartesian product of these two sets, actually it is the product of the two sets, but this is called Cartesian product, A cross B. If you want to write A cross B, this will have ordered pairs. That's why we are considering here, because it will give the ordered pairs. So first we will write one with A, 1 comma A, then 1 comma B and 1 comma C. So first element will be, because A is written first, so first element will be the element of set A. It cannot be the second element. Similarly, 2, with 2 you will write 2A, then 2B, 2B and then 2C. So what we have observed, that each element is an ordered pair. This is what? This is an ordered pair. So each element of the Cartesian product is an ordered pair, and it is not equal to B cross A. If you want to find B cross A, so B cross A will be different. A cross B cannot be equal to B cross A. A into B, A Cartesian product B cannot be equal to B into A. So B cross A, first you can also write the sets and then you can do it like B C A B C cross 1 2 1 and 2. Now first element A will be written with all elements of set A, A1 and A2. Okay, then you will take B, B1, B2. Then you will take C, very simple, C1 and C2. Because this will give you the concept of relation. So I think you understood, but how will you define? And symbolically, it can be written as, mathematically, we can write, or for two non-empty sets, Cartesian product of the two sets is the set of all ordered pairs of elements from set A and B. Or we can write, in mathematically, we can write A cross B, defined as A cross B is a set of ordered pairs A, B such that A belongs to set A and B belongs to set B. B belongs to set B. This is the definition. And mathematically, we can say, we can write a definition like this, or we can say the ordered pair, the set of all ordered pairs. You can write the definition, the set of all ordered pairs AB such that A belongs to A and B belongs to B. A belongs to A and B belongs to set B is called this set. The set of all ordered pairs is called the Cartesian product of set A and B. Called the Cartesian product of A and B, set A and set B, and is denoted by A cross B. A cross B. So like this, we can say Cartesian product of two sets. Method I told you how to write. So we can write the Cartesian product of any two given sets. We can find out like this. The number of elements in Cartesian product of two sets, you can see that it has how many elements? Number of elements, we have seen that the number of elements in set A is 2, number of elements in set B is equal to 3. Then number of elements in A cross B. How many elements are there in A cross B? You can see 1, 2, 3, 4, 5, 6. So 2, 3 is 6. So that means if number of elements in A is P in Q, then number of elements in A cross B will be the product of the number of elements in A and B. Okay. A and B are non-empty set and either A or B is an infinite set, then A cross B will also be an infinite set. If anyone is infinite, suppose A is infinite, then A, sorry, not this A. Yes, A is infinite. If A is infinite, then A cross B will be infinite. If B is infinite, A cross B will be infinite and B cross A will be infinite. Their cross product will be, any one of them is infinite, then its cross product will be infinite. Or if A, out of A and B, if anyone is null set, if A is a null set, suppose A is a null set, A is equal to null set, or B is equal to null set, any one of them is equal to null set, then A cross B will be null set. A cross B also a null set. So any one of them is infinite, then Cartesian product will be infinite. Any one of them is a null set, then their Cartesian product will be a null set. Now we have some questions related to this. So you have seen that product. If we want to find the number of elements in the A cross B, we will multiply this. So like this, very simple type of question that if set A, if set A has 3 elements and set B has 5 elements, then find the number of elements, find the number of elements in A cross B. So as I told you, the number of elements in A cross B is equal to, the formula is number of elements in A cross B. This is n. A cross B is equal to number of elements in A into number of elements in B. The number of elements in A is 3 and B is 5. Therefore, 15 elements. Simple question. So we can find the Cartesian product, we can find the element, and sometimes they are giving the questions like this. Question is, let P and Q be two sets. Be two sets such that number of elements in P set is equal to 3 and number of elements in Q set is equal to 4, and if R4 T1 W3 and R9 and R9 are, some elements are given R in P cross Q. Then opposite, they have given the PQ. Then find P and Q. We have to find the set. Find P and Q, where R, G, W, R, G, W are distinct elements, because we are taking the distinct elements. So that's why they have to write that these are the distinct elements. So, and also write the remaining elements of PQ. Means these are not all the elements. We have to write the remaining elements. Remaining, also write the remaining elements. Remaining elements of P cross Q. This we have to find out. Okay. As we have seen, this is R is there, G is there, W is there. These three elements are there only. So these three elements are belonging to P, because this is the cross product of P, and P cross Q is already given us. And the second is 1394. 1349. So 1349 must belongs to Q. So we got the number of elements, but how many elements are there in P? 3 elements. Okay, and this has 4 elements. So that means it is correct. We don't have any other element. 3 elements we got. So therefore, the set P will be having only these 3 elements: R, G, and W, and Q will have only these 4 elements, because then Q is 4. So 4 elements: 1, 3, 4, and 9. But all elements is not written in this one. 4 3 are 12. They have written only 4 elements, but there are 12 elements in P cross Q. So they asked to write all other elements. So we can write all elements, and then remaining we can delete this and write the remaining elements. So first we can P cross Q. We can write all the possible elements in P cross Q. R1, R, R3, R4, R9. Then we can write with G1, G3, G4, G4, and G9. Then we have W. So write W1, W2, no, sorry, 3, W4, and W9. But they have asked find the remaining, write the remaining elements of P and Q. So these elements you can deduct. So you can write the remaining elements of P and Q are, you can write the answer: remaining elements of P cross Q, P Cartesian product Q are, just you can delete R4, R4, G1, G1, W3, W3, R9, R9. So rest of the elements you can write here. R1, R3, G3, G4, and like this you can write all these, this and this. So these are the remaining. So sometimes they can ask like this also. Now graphical representation of Cartesian product of two sets. How to graphically represent the Cartesian product of two sets? Graph of Cartesian product of two sets. Graphical representation of Cartesian product of two sets. Of Cartesian product of two sets. So in graph actually A cross B, the point of intersection of A, and we will take A, point of intersection of A, vertical line through A and horizontal line. Well, like if we want to represent, suppose we have to represent AB. Okay. So this is just like Cartesian product of uh, Cartesian coordinate system. That's why it is called Cartesian coordinate system. So A, we can take, suppose A is here and B is here. So always we can represent this point. I have told you already, this point is representing A. So always x-axis, on x-axis first element will be taken, on y-axis second element will be taken. So like this we can represent graphically. Sometimes they are asking represent graphically also cross product and show that A cross B is not equal to, and so that I'll take one question. If suppose A is a set of elements 2, 4 and 6, 2, 4 and 6, and B is a set of elements 1, 4, then show that show that A cross B is not equal to B cross A. A cross B is not equal to B cross A, and also show it graphically. Also show it graphically. So A cross B, B cross A. First we will find A cross B, A cross B and B cross A. So 2, 1, A cross B will be 2, 1, 2, 4, 4, 1, 4, 4, then 4, 1, 4, 4, 6, 1, 6, 4, 6, 1, 6, 4, A cross B. And B cross A, this is equation number 1. Then find B cross A. This is equation number 1. B cross A. So first we will take 1, 2, then 1, 4, then 1, 6, and then we will take 4 first element. So 4, 2, 4, 4, and 4, 6. This is equation number 1. So from first and second, we have proved that from first and second, A cross B is not equal to B cross A. Now graphically, so we have to draw these points graphically, means we will draw in Cartesian coordinate system. Like we can have the numbers like this. We can So that point we have to represent, that previous point we have to represent on the graph. That is called a graphical representation. You can take this as x-axis and this you can take y-axis. Now you can write the numbers 1, 2, 3, 1, 2, 3 like this. So we have different numbers A cross B, 2, 1, 2, 4, 2, 1, 2, 4, 2, 2, 1 is this one. This is 2, 1. Okay. So you will have to put the point and write 2, 1, 2, 1 like this. Then 2, 4, 2, 1, 2, 3, 4. 4 will come here. So 2, 4. This will be 2, 4. Okay. Like this, you have to draw the graph and show that from the graph they are different points. You will write the dot represent the cross product of Cartesian product of this set, and these dots represented color dot. You can take different colors for A cross B. For A cross B, suppose choose a red color, and for B cross A, choose another color, blue color, and then you can show the different colors, and then you can show. So you can write that these this is represented by red colors. That points are different from this blue color. Therefore, A cross B cannot be equal to B cross A. This is the graphical representation. Now, our concept will next. We have the concept of diagrammatic representation of Cartesian product of two sets. That was graphical. Now, diagrammatrical. How we can represent in diagrammatrical? So this then tomorrow you'll start relation. So first you see that diagrammatrical representation of Cartesian product of two sets. Diagram means we have, suppose how we will do the diagram, like in the sets we have seen that suppose I'm having 1, 2, 3 in set A, and set B will have AB. Okay. And I want to represent A cross B. So here we used to draw oval diagram, not the circular. Here we will use the shape uh, that shape. So, okay, I will we will make that shape. Yes, okay, we can change shape. So here we will have to make the shape like this. Okay, okay. So this shape, in this shape we will represent the sets. Same thing. It has, this is a set A and this is set B. Now it has elements. How many elements? 1, 2, and 3. And it has how many elements? A and B. So when you represent A cross B means here we are representing what? We are representing A cross B. Representation of diagrammatic representation of A cross B. This one. So A1 will connect with A. Okay. So we can use the straight line. 1 will connect with A. Then 1 will connect with B. Okay. but you have to show arrow also, which is connecting, one is connecting to. Otherwise, the arrow will not be shown. Then A can be connected to B. A can be connected to A, but we are going from A to B. A cross B means A to B. Okay. Then two, two will connect with A, two will connect with B. Also show arrow somewhere. You can show arrow. Then we can have three. Three is connected to A and three is connected to B. So this is the representation of A cross B, diagrammatically representation of A cross B. So now we have some questions in which we have to represent them narrow diagram. This is called arrow diagram. Arrow diagram. So tomorrow we will do some questions on this arrow diagram. Then we have ordered triplet and some theorems on Cartesian product. After that, relations will start.